It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start.
Zero-width Unicode characters. We are talking about the invisible ghosts that are literally hiding inside the digital text we read every single day. These are completely silent, invisible commands, woven right into the fabric of our emails, our social media posts, and even our most secure computer code. Okay, let's dive right into this. I want you to just imagine for a second. What if the very subtitle you are reading right now contained a secret, completely invisible instruction? An instruction that human eyes absolutely cannot see, but your computer can read perfectly. It sounds kind of like a hacker movie, right? But honestly, this is a very real, everyday function of exactly how computers process text. So to really understand how this works, we need to quickly define what a zero-width character actually is. Basically, it's a non-printing Unicode character. It has absolutely zero physical width on a screen. You know when you press the spacebar on your keyboard, you create a visible, empty gap? Well, a zero-width character is effectively widthless. It doesn't render a shape, it doesn't render a gap. Instead, it acts purely as a hidden formatting instruction. Because remember, computers don't read letters the way you and I do. They read code points. And to a computer, an invisible code point is just as real and just as valid as the letter A. What's really fascinating here is the massive difference between human perception and machine reality. To our eyes, both versions of the word hello look completely identical, but look closely at the computer view. That second hello actually has a hidden Unicode character, a U plus 2000B, which is a zero-width space sneaked right into the middle of it. If you tried to log into an account where your password was the first hello, but you actually typed the second one, the database would absolutely reject it, because under the hood, to a machine, those are two completely different strings of data.
AI is moving fast, science is moving fast, technology is moving fast, and most updates online are either too complicated or just pure hype. Welcome to Future Explained, the channel where we take the latest updates in AI, technology, and science and explain them simply.
So why on earth build a system with invisible characters in the first place? Section 1. Why do they exist? The legitimate uses of invisible text.
Let's break down a few of the main types. First up, we have the zero-width space, or ZWSP. In languages like Thai, which don't actually use visible spaces between words, a computer still really needs to know where it's allowed to break a line of text at the edge of a screen. The ZWSP tells the browser exactly where to wrap that text without adding a clunky, visible hyphen. Then we've got the zero-width non-joiner, the ZWNJ. In scripts like Persian or Arabic, certain letters naturally connect to one another. The ZWNJ is used to prevent two characters from joining when they grammatically shouldn't, keeping them physically separate while still being part of the exact same word. And then, oh man, there's the zero-width joiner, the ZWJ. It does the exact opposite. It forces characters to merge. If you've ever used a complex emoji, you have totally used a ZWJ. Notice how the family emoji isn't actually a single image file in the standard Unicode? It's constructed using the man emoji, plus a zero-width joiner, plus a woman emoji, plus another ZWJ, plus a child emoji. That ZWJ acts as the secret digital glue that fuses all those individual icons together into one complex little rendering on your screen. But as you might guess, any tool designed to be completely invisible is definitely going to be misused. Section 2. Hiding data in plain sight. The art of text steganography. Here is the step-by-step on how this absolutely ingenious hack actually works. First, an attacker takes a secret message and converts it into standard ASCII code. Next, they translate that code into an 8-bit binary string of zeros and ones. But here is the crazy part. Instead of actually typing out 0 and 1, they swap the zeros for one type of invisible character, like a zero-width non-joiner, and they swap the ones for another type, like an invisible separator. Finally, they embed this totally invisible binary sequence right between the letters of a normal plain text message. Check out this wild real-world example right from our sources. This looks like a completely standard, benign Craigslist ad selling a snow demon. It's just ordinary text, right? Wrong. Hidden inside the empty spaces between those words is an invisible, encoded link to a website hosting fan fiction. If you copy that exact text and paste it into a decryption tool, those zero-width characters translate back into binary, and boom, the secret link is revealed. You could literally have two people communicating entirely in secret on a super public forum, and no one scrolling past would have a clue. And this goes way beyond just secret forum posts. Companies actually use this exact technique to catch corporate leakers. They'll hand out a highly classified document to 10 employees, but they'll invisibly watermark each individual copy with a unique pattern of zero-width characters. If that document leaks online, they just check the invisible watermark and they instantly know exactly who leaked it. On the darker side, hackers use this to break text signatures in phishing emails. By stuffing invisible characters inside a malicious URL on a clickable button, the text gets broken up just enough to completely bypass security scanners. People even use this on social media to dodge banned word filters, hiding invisible spaces inside restricted words so the automated bots can't read them, but human eyes just read right past it.
Which brings us to the really cutting-edge stuff. Section 3. The invisible AI threat. Manipulating large language models. Now, here is absolutely the most crucial point to understand. Unlike human reviewers who only see the rendered, visible English text, AI models tokenize and read text at the raw Unicode character level. They see the underlying digital fabric. Because zero-width characters are entirely valid Unicode, the AI perceives them perfectly. An attacker can write a hidden instruction, and the large language model will read it and execute it without missing a beat, even while the human operator is completely blind to its existence.
And this brilliantly illustrates the danger. We have what looks like a totally harmless configuration file for an AI coding assistant, just giving it some standard formatting rules. But when we reveal the hidden zero-width characters, we see the attacker has actually embedded a massive base64 encoded malicious JavaScript payload right inside it. The human developer reviews the code, thinks it looks perfectly safe, and hits send. But the AI reads that hidden payload, and suddenly it's generating code with a secret backdoor designed to steal cookies or leak passwords. Researchers actually call this stealth answer-side prompt injection. In a really fascinating study called EvalHack, researchers tested AI grading panels, AIs that are specifically designed to evaluate and score text. By appending a tiny, stealthy payload of zero-width characters to an otherwise totally normal answer, they completely hijacked the AI grader. To a human, the plain text looked a little noisy but otherwise fine, but the AI tokenizer received a strict, invisible command to just disregard the scoring rubric entirely and award a perfect score of 10. And no kidding, it worked. The AI followed the invisible command to the letter. So how in the world do we actually fight back against this? Section 4. Detecting the unseen. Defense strategies against zero-width threats. Thankfully, there are some very practical ways to spot these unseen threats. The simplest one is the arrow key test. If you're ever using your keyboard arrow keys to just move the cursor through a word, and it seems to get stuck or requires an extra tap to move past a single letter, boom, you've just hit a zero-width character. For the developers out there, most professional code editors, like VS Code or Notepad++, have a show invisibles or render whitespace feature that instantly turns these hidden codes into visible dots or symbols. You can also run quick Python scripts or use online Unicode analyzers to completely expose any hidden payloads hiding in your text. Now, at a system level, developers building AI applications have to be incredibly proactive. Best practices dictate implementing super strict Unicode character filtering. You don't just try to block the bad stuff, you need to maintain an allowed character whitelist so that only expected safe text gets through. But most importantly, any text input that gets fed into an AI, especially files pasted from the internet or provided by outside users, absolutely must be sanitized and stripped of any unexpected zero-width characters to prevent these stealth prompt injections. So we've seen how a tool originally designed to bring the world's complex languages together can be completely twisted, used to hide secret links, catch whistleblowers, and even hijack the most advanced AI models on the planet. It really makes you stop and wonder. As artificial intelligence relies more and more heavily on reading the raw, underlying digital fabric of our world, what other invisible ghosts are out there just waiting to be exploited? Definitely something to keep an eye out for.
Future Explained brings you the latest AI, technology, and science updates, explained simply. In every episode, what happened, why it matters, and a real example, no hype. Subscribe for shorts plus deep explanations. So if you want to stay up to date with the future without getting lost in hype, subscribe to Future Explained. And comment below, what should I explain first, AI, technology, or science?